We've seen earlier that there are a couple of different interpretations to a molecular formula that we can have. We can have the molecular interpretation itself, the molar interpretation, and then the mass interpretation. And all three of these can be used to relate quantities or amounts of substances in a reaction. For instance, if we were interested or we are given nitrogen gas coming together with hydrogen gas to form ammonia, we say that we have a molar interpretation of this formula. These coefficients can be used to relate these three quantities together. When we are talking about amounts of substances in a reaction, we are actually talking about stoichiometry and how those are related. So, given any one of these three items, we can convert between those by using stoichiometry, which is that ratio that says for every 1 mole of nitrogen that's used, 3 moles of hydrogen are consumed, we make 2 moles of ammonia. Just like in the sandwich example that we had 2 slices of bread. If you only have 1 slice of bread, well, you can't make a whole sandwich, right? But what we can do is we can actually use the relationship and stoichiometry to relate our quantities. Let's just say, for instance, we are given grams, or the mass of some substance, we're just going to say A. Grams of A, we can convert from grams to moles of A. And now, if we know how many moles of A there are, we can use that stoichiometric ratio to convert to moles of B. And once we know how many moles of B that is, we can convert this into grams, or mass of B. Okay? Let's just imagine for a second that we are given 907 kilograms of ammonia, and we were asked to find out how much hydrogen could be produced. So the question is, how much hydrogen can be produced? Well, as with these stoichiometry problems and most problems in chemistry, we always start with what we know. We have 907 kilograms of ammonia, which, if we want to express that in terms of grams, we have 9.07 times 10 to the 5 grams of ammonia. So let's go ahead and convert between grams of A, or grams of ammonia, to moles of ammonia. And we do that by using the molar mass. We say that 1 mole of ammonia, or NH3, weighs, and this is an approximation, weighs approximately 17 grams. Notice that these two units cancel. We've got one in the numerator, one in the denominator. Those are gone. We're left with just moles, which is what we wanted, or what we were looking for. So this is 5.34 times 10 to the 4 moles of NH3. So that brings us to this step. We have moles of A. Now, through this stoichiometric ratio, we're going to convert from moles of A to moles of B, or in other words, from moles of ammonia to moles of hydrogen gas. Again, we start with what we know. We have 5.34 times 10 to the 4 moles of ammonia. And this is where the stoichiometric ratio comes in. We say that for every 2 moles of ammonia, it requires 3 moles of hydrogen. So once we actually do this calculation, we'll notice that the units, moles of ammonia and moles of ammonia, these are going to cancel. We're going to be left with moles of hydrogen, which is what we wanted. So we take 5.34 times 10 to the 4 and multiply it by 3 over 2. and we should get 8.01 times 10 to the 4 moles of hydrogen. So now that we have that, we are currently here at moles of B. We need to do one more conversion from moles to grams. And again, we need the molar mass in order to do that. Molar mass is grams per mole, right? That's our conversion between there. So we start with what we know. We know that we have 8.01 times 10 to the 4 moles of hydrogen. We are going to multiply by the inverse of the molar mass, or I'm sorry, the molar mass itself. So 1 mole of hydrogen gas weighs approximately 2.02 grams. Okay, and again, notice our units. We have moles of hydrogen here. We have moles of hydrogen here. These two, those are going to cancel, and we're going to be left with just grams of hydrogen, which is what we were interested in. We actually do this multiplication, 8.01 times 10 to the 4 times 2.02, and we should get 1.62 times 10 to the 5 grams of hydrogen. So the original question is, how much hydrogen can be produced? This should actually say how much hydrogen is required. Sorry, I read that backwards. How much hydrogen is required in order to produce 907 kilograms of ammonia. So ultimately, we were given grams of ammonia. We converted to moles. We converted moles of ammonia to moles of hydrogen. And then lastly, from moles of hydrogen to grams of hydrogen.